Hi, this is Sadiq, and I'm a computer science student. For my Kaggle AI agents Capstone, I built the space operations copilot. The problem I set out to solve is hallucination in the aerospace. If you ask a standard LLM to calculate the exact azimuth and elevation of the International Space Station, it will often hallucinate the coordinates. The in-machine control, hallucinated math is completely unacceptable. My goal was to build a system that leverages the natural language understanding of AI but strictly confines the physics calculations to deterministic math engines. We need absolute precision. This is SATCOM-CoPilot. So this is the SATCOM-CoPilot, a multi-agent space operation system. 4 AI agents working together like NASA mission control. To answer one question, where can I see a satellite from my city? And to run this, you can just simply type any command, which I typed when does the ISS pass over when you run. Here the ISS is satellite name. After hitting enter, the flight director routing machine works. Watch what happens when I ask a question in plain English. The flight director agent classifies my intent and extracts the entities, the satellite and the location. It routes the task to the GNC console, which pulls live orbital data from central task and computes real pass windows using SGP4. This is deterministic physics, not language model guessing numbers. Choose which type of satellite you need to track. If you select 6, you can track all the 6 satellites which you want and hit the browser. This is the live tracking system of SATCOM-CoPilot. This is the Open-Meteo forecast and score sky visible using a layer cloud algorithm. The result, exact pass time, evaluation, direction, and a plain English verdict on whether I will actually see. Here the map refreshes after every 20 seconds for it to track live locations of the satellite. Here you can see list of all the satellites that are present in the map. Here is the example, the HST Hubble satellite. The timestamp, the latitude, the longitude, the altitude, and the speed with illumination. It can also track an entire fleet. Here are the 5 satellites at once. The IAS, Hubble, Tiong, goes 16 and lands at 9, plotted live on a dark theme map with visibility footprints and ground tracks to my observer location. The map auto refreshes every 20 seconds, recomputing every position with real orbital math. So, under the hood, this is a hierarchical orchestrator working system. The flight director, the consoles never talk to the users, and a fourth agent, the QA sentry, validates every response against pedantic schemas before a human ever sees it. If a weather API fails, rule all 005 degrades gracefully. The system still answers and it tells you the data is degraded. The agent cannot lie and the agent cannot crash. All the agent expertise is packaged as 4 custom agents: a router skill, a satellite tracker, a weather validation skill, and a QA evaluator skill governed by a written guardrail constitution in agents.md. Deterministic tools, the pedantic data schemas, and 16 behavior-driven test scenarios in Gherkin keep everything verifiable. Adding a new console means writing a new skill, not rewriting the system. So on the conclusion, the SATCOM Copilot, real orbital physics, real with 4 cooperating agents that are live and guardrails that make hallucination architecturally impossible.